Okay, pause and try this one. Question is about this image. All right, what is true? Gotta be careful sometimes to say what is not true. All right, is this exocytosis? It is not. So exocytosis is how large, m large molecules or large things are transported. So the squiggly thing, we need to get rid of that large molecule. All right, we're gonna package it up into what's called vesicles. Right, these are vesicles also made up of phospholipids. All right, and then that large whatever it is can leave the cell that way. Okay, because those large things are simply too large to like fit through the phospholipids. All right, so it's not A, it's not exocytosis. All right, let's pick a different color here for B. All right, so it's not A. All right, does not require energy. Well, that's passive transport. Is this passive transport? Does not require energy. It is not passive transport. You can see this here is going into the crowded area. You can see that the arrow is pointing. All right, let me do this again because it's not going through it's going through the protein. It's going into a crowded area. This area is more crowded. So that is not passive. Passive transport would go from the crowded area to the less crowded area. High concentration to low. So B is not correct because that's the drawing is not going to the less crowded area. All right, so B is not correct. All right, stops when equilibrium is reached. No, that's also passive transport. Passive transport has to stop when both sides are equal. Okay, so I'm just going to throw in a different thing here. All right, 4 dots on the outside of the cell, 2 dots on the inside. All right, we bring one over. Now it's 3 to 3. That stops. Passive transport stops. You need a concentration gradient for passive transport to work. Concentration gradient. All right, what that means is you need more on one side than the other. If you have 3 and 3, passive transport cannot happen. Right? So C is also not the answer. This is not passive transport, is what I'm saying. All right, it creates a concentration gradient. That's right, it is creating a crowded area. It's creating a crowded area. Look at the arrow, it's going into the crowded area, taking this stuff, moving it over there, making it even more crowded. That is, well, pause the video. What is it? What kind of transport is this? All right, it's active transport, specifically protein pump. All right, it's going to use ATP. This is going to use ATP to pump these potassium ions, which is what K is, into a more crowded area.